What's going on, guys? Been a long time. Take a look around. This garage has recently been demoed. Well, 80% of the way demoed due to having a fire in here. Now, as you can see, it is extremely dirty. There's walls missing everywhere. This place is a shit show right now. But we are going to be building a 2JZ motor, bottom to top, forged internals, the whole works. We're going to be building it in this garage, okay? So as far as building motors goes, you can take your rods, your pistons, your crank, your bearings, you can slap it all together, and guess what? Might work perfectly fine. Might be reliable, might last you years. But doing it the right way, one, will give you peace of mind. Two, most likely will make the motor more reliable than it would have been had you just slapped it together. In today's video, what I'm going to do is, and you guys should, if anything, watch this video because it's not super challenging to do what I'm about to show you how to do, which is balance a rotating assembly. And to give you a little premise on it, basically what balancing a rotating assembly means is that all of the pistons, all of the rods, and all of the piston pins are nearly, because they're never going to be exact, but they're going to be nearly identical in weight. Now, as you can see here, what we have is, this is the CP SC7464 set from Titan Racing. So this is 9-to-1 compression ratio, right? Here's all the pistons, piston pins, we got all the rings, all that kind of stuff. A lot of you guys, and I know a ton of you out there, use Manley, okay? Now, you guys can rip on it, make fun of it all you want. Manley makes good rods. They are way better than factory, and they are tough, okay? No, they're not the nicest stuff you can get out there, but they work, okay? And the other thing, and this is what we're about to get into today, weighted, okay? You actually have physical measurements of what each weighs. Now, what we're doing today is we're going to be balancing the rotating assembly. Now, what do I mean by balancing the rotating assembly? Here's what I mean. This piston is going to attach onto the rod. I'll get more into that in a minute. We also have the piston pin, or the connecting pin, okay? All of these need to weigh the same amount. They're never going to be exact. What we have is, this is in gram measurements, okay? So see all these, how they're a little different, okay? And Manley, they actually send you this card, okay? You see this? So total weight in grams, they got big end, pin end, the whole works, okay? Long story short, we'll cut through all the BS. When an engine, this 2JZ in particular, when this 2JZ is spinning 8,000 RPM, that means the crankshaft is physically doing a 360 8,000 times in a minute. So, first things first, let's pull them out, okay? Make sure all your fitment is exact, okay? This should be a little snug going in. It should not be impossible to get it in, and it should not ever have any kind of slop when you're putting it together. So, the way this works is you take your piston, okay, and here's the other thing. Be careful with these. You ding them, you start marring them, you're going to run into trouble. So you take your piston, we're going to pull this back out, and I'd recommend lubricating them with some oil. Now, these are all fresh out of the box. The piston pin actually has a little bit of lube on it, so does the inside of this. Okay, and so what you're going to do is you're going to connect it all and put it together. Make sure everything fits. That's the first thing. Before you start getting ready to drop the pistons in and go through all that, make sure what you ordered is physically what you have. Okay, so I'm going to assemble this one real quick. All right, so all I did, grab the piston, grab the rod, slide the piston pin in. So the reason I brought up 8,000 RPM. 8,000 RPM is going to be about the rev limit for this one. It might be a hair less, maybe 75, but just to give you a reference point, okay? At 8,000 RPM, this is moving up and down in the bore 133 times per second. Now, if you've ever just felt the weight, okay? The weight of the piston, connecting pin, and the rod on a 2JZ or any motor, they have some weight to them. They don't weigh nothing. They have, well, I can tell you how much they weigh exactly, but that's not what we're doing yet. So the reason I bring that up is because balance is the most important thing in the motor, okay? What you want ideally is you want all of the pistons, pins, connecting rods to weigh the exact same. The crankshaft is already balanced, okay? The crankshafts are balanced from the manufacturer. You see all the big lobes on them? That's what they're there for. They're there so that the crankshaft has a neutral balance. That means when it's spinning, there's no ends on the crank that are tugging or pulling on the bearings. It's nice and true. So what we want to do is we do not want to throw off the weight of the crankshaft or any of the rotating assembly. We want it to be the same. So what I did is I grabbed my first rod. Okay, they have big end, small end weight. So what I'm going to do is I'm going to disassemble this. And what we'll do is we'll slide the pin out. So we'll set this down. You guys that film know this is not easy with one hand, but we're going to pull the pin out. We're going to set it somewhere safe so it doesn't slide or roll away. I'm going to pull the rod back off. Now this is an assembled rod. Okay, it's not torqued or anything like that. It doesn't have bearings in it. But what we're going to do, we're going to turn this on. We're measuring in grams. That is probably the best way to measure this. That is the way they measured it. That's the way I would recommend to weigh them. So what we'll do is we'll take this and we'll set it on here. We have 613.5. I'm going to pick it back up, set it back down, 613.4, okay? And I usually do this about 3 times just so I know it's a true measurement, okay? So 613.4 is what we're going to roll with. Now, if you take 175.7 plus 437.9, that gives you about 613.6. Now, we show 613.4. Now, when we start dicing the decimals on grams, that's what we're after, okay? We're at the grams total. That is the most critical part to be the same. The tenths that follow, okay, ideally, we'd like to get them as close as possible. They're not far off in measuring that. Now, let's start with the pistons, okay? You guys would think, you'd go, okay, CP pistons, sold from Titan Racing. They got a really, really good reputation. That's Corello in general. Very, very high quality stuff, okay? I'm a huge fan. I used to run them in the race bikes and motocross. They work awesome. You would think the pistons weigh the same. I'm here to tell you differently, okay? So I'm going to take the second piston. There's the first one I pulled out. We're going to set it on here. 322.5. Do it again. 322.6. Okay. So, is this the nicest scale in the world? No. But is it going to get us pretty close? Yes. So, I'm going to go with 322.55 or 0.6. Close enough. If we set it towards the corner, I bet it'll throw it off. Yeah. See? Ideally, you want it right in the middle. But we're not going to start dicing about the scale. So if you guys remember what that was, I'm going to set it on here one more time, 322.5. Now we're going to grab this guy, okay? So move this piston over here. Same exact piston, just a different one out of the box. 323.4. 323.4. 323.5. Do you understand what I'm getting at now when I am talking about balancing a rotating assembly? There are slight differences. Okay? Now CP, and if you buy high quality pistons, they're going to be pretty dang close. Could you just slap this together, throw it in there, and it'll work great? More than likely, the answer is yes. But when you're getting into the science and when you want to build something that you're going to thrash on and you're going to be really abusive on it, get the balance proper. So that is what I'm about to show you how to do. Okay, so these, I'm actually going to ignore these. I don't care about the big end and the small end. I really don't. Because what I want to do is I want to take the weight of the assembled rod with the piston, with the pin, and I want to get them as close as I possibly can, okay? So what you want to do is add these together so that you have total weight for the assembled rods. Total weight. You're going to weigh all the pistons, and you're going to label them 1, 2, 3, 4. So what I'm going to do, just to give you a reference, take a Sharpie out. What I'm going to do is I'm going to write number 1. Okay, so we got 1 on the piston. Now, number 1, we'll go back, and we're going to weigh this. We're going to do it a couple times, 323.4, 323.5, 323.4. Okay, so I'm going to roll with 323.4. And what I'm going to do is write 1, 323.4. Okay, so that's piston 1. Okay, we're going to set it off to the side. And keep these clean. Keeping them clean is super important. Now on this one, we're going to write number 2. Okay, so what I'm going to do, write number 2. We're going to set this back on here. So now we got 322.6, 322.6, 322.7, 322.6. So 322.6. And that's for number 2. Okay, you guys get the general idea. So I'm going to go through, I'm going to label them 1, 2, 3, 4, 5, 6. And we're going to take all this weight here. And we know what they are because they have the number on them. The weight's not going to change as long as you label them correctly. And then what we're going to do is we're going to add up all the weight of the rods. So I'm going to label the rods. That's going to be 1, 2, 3, 4, 5, 6, etc. Now, that's not the order that it's going to go in the motor. That is for the sole sake of keeping them organized, okay? So if I label this 1 and the next one to it is 2, well, what I might end up doing is I might end up taking 2 and putting it on number 6 piston. And then I'm going to erase the labeling that I did, and I'm going to mark it cylinder 1, cylinder 2, etc., etc. So we're on the last rod here, number 6. You got 615, 615, 1, 615, 1. All right, so I write it on the rod. So 615.1 here, 615.1. Now, I haven't done all the pistons yet, but take a look, okay? Not the same. And sure, you know, it's minuscule, it is, but we're here to balance. We're here for perfection. The inside of a motor, the more balanced you have it, the more abuse you can give it without failure. So, these are all now labeled. 1, 2, 3, 4, 5, 6. I got all my weights on there. So then we're going to move to the pistons. I've done the first 2. I got to knock the rest out. Then I'm going to weigh the pins. Once we have that all figured out, I'll show you the next step, but it's literally basic addition and subtraction. Okay, guys, I've got them all measured. So, it goes to show you the quality of CP. All those pins are perfectly spot on. So, we didn't even really need to worry about those, but depending on the manufacturer, you would be surprised. You will find slight variations. So, now this is where it just literally math skills. So here's what we got. First thing we want to do is we want to identify by marking it. We want to identify the lightest piston, okay? So if we go through here, we got 323, 22, 3333. Okay, 322.6. So we're going to put a 1 next to it. That is the lightest piston that we have. 322.6 grams, okay? So piston number 2, that's the lightest piston that we have. Now, what we want to do is we want to find the heaviest rod that we have. So what's the heaviest rod? So we look through here, number 6. So I'm going to put a 1 next to these. So 322.6 plus 615.1, we do the math. So we write a new sheet over here. And I'm probably going to have to pause the video to do this because it's hard to open my calculator while I'm filming and do this. But essentially what we're going to do is we're going to write them in order here, okay? So we're going to go 1, 2, 3, 4, 5, 6. All right, guys. We got the rotating assembly balanced. So here's why I'm doing this. When you send your engine off and the machine shop balances it, right? You send them your crank, pistons, rods, pins, etc. And they balance it. What they do in industry standard is to be within 2 grams of total mass. So the heaviest versus the lightest, 2 grams, okay? Now, if you're over that, that isn't considered a balanced rotating assembly, at least by industry standard. You get into like Formula One, I'm sure they got that down to 10,000ths of a gram as far as balancing. Now in the real world, especially when you're talking LS, JZ, all that kind of stuff, you send it to a machine shop, they will get it as close as they can, which typically is within 2 grams. So the reason that I'm showing you guys this is because I just did the balancing and I achieved a total deviation of 1 gram. Okay, that means that instead of sending it to a machine shop to have it balanced, right, I just saved you, some charge $180 to $300 depending on what machine shop you bring it to. And they basically do exactly what I just did. Now, you can get into the finite science, right? You can get the Dremels out. You can start cutting into them a little bit. You got to know where. You got to know how. For the average engine builder that's not a professional at it, don't do that. Highly unrecommended, because you take weight out in the wrong area, you start weakening points that shouldn't be weakened, bad deal, okay? But I'm going to show you what I got here. Again, you guys know how I labeled this. This was super easy, okay? You weigh them, you label them, done. Now, what we do, like I told you before, we find the lightest. So first thing you do, lightest to heaviest. Super easy, okay? So lightest piston. So these numbers on this column here, right, are the order of which they get assembled. So this column and then this outer column. You can draw it however you want. Find the lightest piston. Well, that ends in a 2, 322.6. That's the lightest piston. Now, heaviest rod, 615.1. That's why I got a 1. So then you come over here. Piston number 2. Rod number 6, 937.7. And as you go through this, you find the next lightest, the next lightest, the next lightest, the next heaviest. You guys get the general idea, I would hope, okay? So if we go through here and we find total mass, okay, so this is piston plus rod. Now we don't need to count the connecting pins because they're all identical. I went through here. CP did a phenomenal job machining those. There's 0 deviation. So going through here now, right, what is the heaviest assembly that we have? It's right here, 937.9. That's the heaviest one that we have. What's the lightest one that we have? 936.9. 1 gram of difference, okay? Now, I want to give you an example because some of you might be watching this and you're like, you don't need to do that crap, blah, 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 blah. Well, let me just give you an example, okay? If I was to just randomly pull a piston out of the box, randomly pull a rod out of the box, and I slap it in that bottom end, right? What I did is I took the heaviest piston and lightest rod, vice versa, so lightest versus heaviest, okay? 935.6 is what I could have ended up with. None of these are 935, if you can see that. Okay, 935.6. Well, if we go heaviest, and we put the 2 heaviest together, that's 939, right? None of those are 939. The difference is 3.4 grams. That's not a balanced rotating assembly. Now, on top of that, right, if you send it to a machine shop, the spec is 2 grams. So if we can get it within 2 grams, that's a balanced rotating assembly, okay? So literally what I just showed you how to do is literally what the machine shop's going to do. So you are welcome. Saved you some money. Now it is super simple, okay? What we do is we follow our log here. So now that we've done that, now we can start assembling them, get them ready to drop them into the block, and that will be on the following video. I'm going to show you how to put the bearings in, because there's a right and wrong way to do that. And even before we put the bearings in, I'm going to touch on the most important things to do with the block before you start to even assemble anything.